We'll start.
Yeah.
Good afternoon. Welcome to the Ph.D. Viva exam of Amit Singh Chandra, guided by Professor Chandan Sarangi. We have two examiners who have joined online. Dr. Anupam Asra from Indian Institute of Tropical Meteorology, Pune, and the internal examiner is Dr. Tanushree Persai from our department. So the procedure is the candidate will present a summary of his work for about 35 minutes. After that, we have questions from the examiners, then the DC members, and if time permits, we'll also take questions from the audience. So get started with your presentation.
Thank you, sir. Good evening, everyone. My name is Amit.
Just check if you are audible. Just check.
Okay. Am I audible?
Yes.
Yeah. Thank you.
Yes.
Thank you, sir. Yeah. So my name is Amit, and I am here to defend my thesis entitled "In situ observations, characterizations, and regional impact of dust storms over the Western Himalayas." So I'll be going through a short motivation of my study, followed by the objectives and the results. So motivation was like a lot of studies have already been published regarding the dust storm presence over the Indian regions, and they have stated that these dust storms are not only coming from the Thar Desert, which we have in India, also from the arid regions of neighboring countries such as Afghanistan, Pakistan, but sometimes even far from UAE and even South African deserts. So their dust is being transported from those regions to the Indian Himalayan regions as well as Indian plain regions. A lot of studies have been done in the plains with respect to the optical properties and their sources. But what are the sources and what are the optical properties, how they are governing in the higher altitude locations, have not been studied yet. So with this, when I went through all the literatures, I could find some research gaps which I wanted to fulfill. The gaps were that characterizations of dust storms properties based on the sources such as their optical natures, their size natures, their refractive index has not been calculated or measured yet. Second, the scarcity of in situ measurements of light absorbing particles, because dust also act as light absorbing particles. So these particles have very been less measured or not yet measured up to the very much extent over the western and central Himalayan regions, also in the atmosphere and snow. Third, these dust particles, because they have their own origin sources and they have their own regional effects, how they act as an ice condensation nuclei has not been studied yet. So based on all these research gaps, I formulated my objectives for my PhD. So the objective was to study this dust storms' optical, chemical, microphysical properties, how they affect on snow, and also their indirect and direct effect by acting as like changing the refractive index, indirect effect by acting as an ice condensation nuclei, further affecting the cloud formation and other processes. So point-wise objective is to classify dust storms based on their optical properties and source pathways, and to study their snow darkening impact. Second was to measure dust storms' optical properties and calculate their complex refractive index. Third was to measure the ice nucleating particles during dust storms events in the Western Himalayas. So I'll be following it one by one. So for this, all the three objectives, some grouped methodology is over here. So I choose a particular site in Western Himalayan region for the in situ measurements of aerosols. So this is the Himalayan region, Western Himalayan region, and I have highlighted a pinpoint location Dundi. And the pathways I'm also showing by air mass pathways, which is being like the aerosols are being transported to that pathway. The reason for choosing this site was because Indian Himalayans, as this site acts as a barrier. So all the dust storms which are getting into the Indian Himalayan region has to go through all the barriers, and within all through that prairie barriers, one of the location was Dundi, which is very prominent. As we can see, all the pathways are leading to the particular point. It is stated at that particular point. This is a temporary lab setup which was installed at Dundi. We have the optical measurements by scattering like nephlometers from athlometers. size distribution measurement, submicronic by SMPS, and the macro scale from 1 micron to 30 microns by OPC. We also have centimeter information to get the vertical extent. So this was a temporary lab setup to measure the in situ measurements over Dundee. Apart from this, we use other instruments as like total extinction, short wave, long wave radiations, AOD measurements, BC measurements. We all did for this. There was a 2-year campaign in 2022 and 2023 to like identify and monitor dust storms and their effects on the regional climate and also on snow. Apart from this in situ measurements, we also use satellite data and model data. Satellite data from MODIS, MIRA2 model data, high-speed model data, snow albedo reduction data. So these were also used. And apart from this, there was another station in Central Himalayan region in Uttarakhand, Nainital, Mukteshwar. We also used their long-term in situ observation data to get our hypothesis done. So from all this methodologies, I'll just going to give you an objective-wise methodology how I use this to get these methodologies to get my objectives done. So objective 1.1 was to get this effect, monitor these dust storms. So I used, there is a site, as I said, Mukteshwar in Nainital. They have long-term in situ measurement data of PM and optical properties. So I used those in situ measurement data. Also the MODIS satellite data to get, and when I went through these data with the high-speed model, when I combined this, I got that event identification and classification. For objective 1.2, because it is clubbed with the previous objective, so after identifying these events, so I classified them into 2 types, mineral dust event and polluted dust event. Then when I used MODIS snow data with for the western and central Himalayan region, I could say that how they are decreasing the snow albedo. For objective 2, I used 2023 campaign data. From those data, I used the optical and macrophysical data put into the my model to get us the real and imaginary part of diffractive index. For objective 3, I used PM 2.5 and 10 filters from the 2022 and 2023 campaign. Also put these filters in by various methods and process into ice nucleating chamber, which gives us the frozen fraction, and from there we calculate the ice nucleating particles. So this is just a methodology of my objectives. Now I'll be going on the results part, which will have even their own methods if necessary. So first objective was to classify dust storms based on their optical properties, source pathways, and study their snow darkening impact. So I used this MODIS dust optical depth data. As you can see over here, I have presented, this is just an example of one event. So here you can see a time series, a 9-day time series of dust optical depth from 1 June to 9 June. And I'm stating that when dust storm is progressing at my desired location, that is the red dot over here, small circle, that is Mukteshwar region. So you can see the yellowish part or the yellow color is increasing in that bounding box of 400 square kilometer, the square box you can see near the red dot. So my hypothesis was whenever dust is approaching there, we can see the yellowish part increasing in that location, and that was, I'm claiming it as a dust storm. And to verify this, I also looked into the Calypso overpass, which was, Calypso is a LiDAR satellite. So it tells us that what is the vertical distribution of these aerosols and what type of aerosols are they. So Calypso also says that yes, there is a presence of dust over there and verified by a Calypso subtype. After getting through this, so now from this we can get this dust storms identification based on satellite measurements. Also, I used this from the satellite measurements, we also use in situ measurement data simultaneously to verify whatever is getting from satellites, are our instruments able to measure those things or not. So from this approach, we have this PM time series, PM10 and PM2.5 concentrations. We saw that whenever we are getting DOD dust optical depth increase with respect to time for that particular location in that bounding box, we are also getting the PM increase from our in situ measurements. So thus this also verifies whatever we are seeing from satellite, we can also get from in situ measurements, verifying that presence of dust from different locations to that location. So yeah, after identifying these dust storms, we wanted to classify these dust storms. When we looked into the optical properties, daily event optical properties, we noticed that there is an increase in scattering coefficients, which is likely due to the presence of dust storm as it has a scattering nature. But also we could see that there is a huge enhancement as dust storm approaches, huge enhancement in the black carbon concentration as well. this gave us an idea like dust storm is supposed to increase the scattering coefficient, but absorption coefficient is also increasing. That is due to the presence of black carbon. Then we wanted to know that does every dust storm has the same effect or not. When we looked into the multiple dust storms, we could get 10 dust storms for which we have the in situ measurement data and also the satellite data. We could found that not all the dust storms are having increment in the black carbon concentrations, but only few of them. I said only half of them are having like black carbon concentration increment with respect to their background conditions, while others are not having. So now I called those dust storms which have the black carbon increment as PDE. By PDE I mean polluted dust event. Why I'm saying it's polluted, because it is not only dust storm, it is mixed with the black carbon concentrations. So after getting this, that there are two types of this dust storms which are approaching the Indian Himalayan regions, we wanted to find out like what is the major cause of these different kinds of dust storm. What is the making the difference? Why are these two dust storms in different behaving differently? So we looked into the pathway, like through which pathway are they coming over before the possible location. So the star mark location is my Dundi. In the left panel, this is a high split model which we ran. So when I use the high split, the spatial trajectory shows that these are coming from the nearby Thar desert, or sometimes from the arid regions of Pakistan. But the difference is not much more in the spatial variation. But when we looked into the elevational variation, bottom two panels of the left side, we see that whenever there was mineral dust episode, right, which is not mixed with the black carbon, the elevational variation is not varying with respect to the background conditions. But when we see the polluted dust storms, it has elevational variation with respect to the background. By mean elevation variation, I mean is that before reaching to the desired location, my measurement site at Mukteshwar, they are traveling below the boundary layer height. By traveling below the boundary layer height, they are getting mixed with the local pollution sources. Maybe pollution sources from the traffic emissions, maybe from industries, maybe from other sources. They are getting mixed with those kind of pollutions and carrying the absorbing part along with the dust to the desired location, that is Mukteshwar. And people might say that this is high split is not valid, but we also got the same thing from the Calypso satellite as well. So Calypso satellite, I have shown here two example images for MDE, for mineral dust event, and polluted dust event. Yeah. So this is the dust layer for the mineral dust event, for the mineral dust. So you can see the extent of this vertical is around 5 kilometers. So this is the star mark location, Dundi over here. So it is reaching from top and bottom both, but most of the higher frequency or higher density you can see in the top. While in case of PDE, as you can see, the trajectory is going from down and then it is reaching towards the desired location. It means before reaching the desired location about 3 kilometers to 2 kilometers, it is traveling below the boundary level and incorporating all the pollutions from this local sources to the location. This was the reason why we are getting two different type of dust storms over the western Himalayan regions. So after identifying that there are two different types and we could justify their sources, that is why there are two different types, we wanted to know what are their effects on snow surface or glacier surface. We looked into this, this is the snow albedo reduction data from the event. So the top panel shows here the effect of this dust storms. So I combined all 5 dust storms of mineral dust and then looked at what is the albedo reduction at that time when this event approached over here, and for the polluted dust. We also categorized one new kind of event which I called as BC event. By BC event I mean there was no approach of dust, only black carbon concentration was increasing at that particular location, Mukteshwar. So you can see here when I talk only about the polluted dust, you can see the dark concentration is only for the mineral dust. Now you can say when mineral dust are coming, they are polluting more. But when we look with respect to their background, so the bottom panels are event minus background concentrations. It means that during 3 to 4 days back, what was before, and when the event approached, what has changed. So this is the only changed part. When we looked into this part, now we can see the darker part is for the polluted dust event. So it means that the polluted dust event has a more effect compared to this mineral dust and black carbon episodes. So I'll show you why this graph. This is a PDF graph for the same thing for the western and central Himalayas regions combined. So dotted lines are the background conditions and blue, the solid lines are the event conditions. The blue, red and black are respective events for mineral dust, polluted dust and BC events. You can see over here when this event approached for this polluted dust event, approximately 4% change in the snow albedo reduction was seen. Whereas compared to this like dust event or mineral dust event, it was around 2.5%, and for again black carbon event was 2.5 to 2.7% only. So it is said that black carbons are mostly absorbing, but when they are mixed with the dust particles, they become more and more absorbing in nature, thus affecting more towards the snow albedo reduction. So from this, I complete my first objective, stating that there are two different types of dust storms based on their two different type of pathways, and they have different kinds of effect on the snow albedo reduction. Now coming to the second objective, to measure the dust optical properties and measure calculate their complex refractive index. So after coming to know that there are different kind of dust storms, already people have known about refractive index throughout, like they have measured at various locations in India and over the world. But I wanted to find out, because now there is a new word, polluted dust storms. I wanted to know what that polluted dust storm is having effect on refractive index. So this was the measurement done over this Manali region. As I showed, the instruments were there. So we were there for around 3.5 months. So this is a 3 months measurement for this PM concentration, BC concentrations, size distribution, optical measurements. We did all that because these all are the inputs for this my model to calculate the refractive index. From this 3 months measurement period, we could identify one polluted dust storm event, as the methodology was as previous shown in previous objective. So we could find there was one polluted dust event, and we could also verify this polluted dust event based on two things. One was the mirror 2 model. So this is dust flux for the background condition. So by background I means like 5 to 6 days before the event approached, and this is the event period. So you can see the dust flux. So at this star mark location is the Dondi location for measurement for the measurement site. So whenever dust was approaching, so in the background we could see that there was not much dust concentration over there. Dust flux was less. But as soon as the event approached, we can see the approach from the dust is getting from this arid regions to this desired location. Also, when we looked into the right side panel, the optical properties, we could see that as soon as the dust approaches or the dust storm approaches, we can see change, static change in the scattering coefficient, absorption coefficient, and again the black carbon concentration. As I stated in my previous objective, polluted dust events are those events which have increment in the black carbon concentrations as well. So here also again same thing is happening. Thus it is verifying that this is also a polluted dust event. Further, because in earlier objective we don't have this scattering and absorption coefficient at multiple wavelength, I couldn't figure out this AE classification provided by Kappa et al. 2016. Now this also states that this part, large particle BC mix, this has a lesser fraction, but this part again the fraction of this thing is increasing from around 10% to around 50%. 30% around increase in fraction of this BC mix particle again tells us that this event is polluted dust event. So after identifying this dust event, that this is polluted dust event, we wanted to now calculate its refractive index. And the methodology to calculate refractive index goes like this. We have these blue boxes are the input parameters for this. We provide a particular fixed wavelength. So I have chosen here around 550 nanometers and also 500 nanometers for this particular example. Geometrical median diameter I get from this size distribution measurements, the imaginary and real part. So we give iterations. We provide 10 power minus 6 to 1. So iteration factor is 10 power minus 6. So we have around 1 lakh cells of imaginary part and around 1000 cells for real part to get the iterations done. So when we put these parameters into my model, we give scattering and efficiencies. And when we also incorporate size distributions, we get scattering and absorption coefficient from the model. For this, I also did, because nephelometer is Aurora 3000, so it has only 3 wavelength channel. So it is also different from this affluometer channel, which is E33 model. So I did extrapolation using a scattering angstrom exponent to get the same wavelength for the nephelometer and affluometer. And also we have to combine the conversion for diameters. Use the technique used by Baldo et al. Because SMPS measures the diameter in this is mobility diameter. OPC measures in optical measurement, like it is optical diameter. So to combine both, I have to measure, take both simultaneously. I have to combine both of them into the geometrical diameter. So for this, I used merging for SMPS and OPC diameters. SMPS size range was chosen from 20 nanometers to 700 nanometers, and for OPC it was 0.9 to 32 micrometers. When we get this scattering and absorption coefficient from model, we have also measured this from ethylometer and nephelometers. We calculate the error. The minimum error for that iteration is the refractive index. I mean, when I iterate for various n and k part, the minimum error at which part I get, that is my real and imaginary part of refractive index. So this was the methodology, and what we could found is I calculated for polluted dust event, and it is shown over here. It is shown that from the background it is increasing again with respect to event. It means that dust storm is enhancing the refractive index properties, and imaginary part is also there, it is also increasing. So the real part also shows, the real part usually tells that how much light is bending due to the presence of aerosol. It means mostly the scattering nature. But again, imaginary part tells us that how much the particle has the absorption nature. Here, an increment in absorption particle is also seen, thus again verifying that it has been affected by the polluted dust storm. And you might say because the peak has not been deviated much, but if you look into percent-wise fraction, it is around 50% increment with respect to polluted dust storms. I also compared with my study with all the studies which I could found for the Indian regions and also other regions of the world. And I could see that my studies were lying in their range, but also have some different, like the values were sometimes very different with respect to the polluted dust storms. Because till now people are dealing with dust storms, and sometimes only lab experiments are based for the standards material for the black carbon aerosols and emitter aerosols. But they have not said that they are doing with the polluted dust storms, or they have not segregated it. So I just, the green part issue over here is for the polluted dust storms. Also, we could find one small event that was having enhanced in black carbon concentration. So we could find this black carbon, for that black carbon event, we also calculated this refractive index. And yeah, if a question comes, why is refractive index compulsory? Because when we measure scattering and absorption coefficient, it also tells the same thing, but it is not, because scattering and absorption coefficient is a parameter which is dependent on the concentration. If dust concentration is more, we might get more and more scattering coefficient. But refractive index is an intrinsic property. It does not depend on the size, like mass or whatever the concentration is present. It has their own nature. So this is the point why we calculate refractive index, and also why I calculated apart from this knowledge, because few people like Mose et al. And Venezuela et al., they have said that slight change in refractive index, even from 1.4 to 1.5, might lead to 12% uncertainty when we calculate radiative forcing from it. And people use refractive index information to calculate radiative forcing, which has been using in IPCC reports and others for policy makings and other things. So from this, I submit my second objective. I completed my second objective by identifying a polluted dust storms and calculating its refractive index. Now I come to my third objective, which was to measure the ice nucleating particles during dust storms. Because dust storms are there, they have some of the particles might act as cloud condensation nuclei, some of the particles might act as an ice condensation nuclei, depending on their composition of the particles. If they act as an ice condensation nuclei, they will enhance the cloud formation, cloud processes, everything other things. So this is why it was necessary to measure the dust storm nature of acting as an ice condensation nuclei over their region. So this methodology was very broad, so I just have mentioned a few points. Based on filter selection, the methodology differs. So for this I used Teflon filters and also the quartz filters. So from these two different filters have two different kind of methodologies. But eventually, like somewhat they are the same. I'll be explaining the different methods over here. For quartz filters, we use punch filters method. It means I take a filter paper, I punch each time, take a punch, and I have a PCR plate which has 96 wells. I take each single punch from the filter paper and put into the well. Then it was submerged with 1 microliter of this milky water, and then it went for the freezing. While when I take Teflon filters, it cannot be punched, so it has to be submerged into the around 10 ml to 15 ml of milky water. It is the wash method, and then it is being sonicated so that all the pollutants which are getting trapped on the Teflon filter papers do come out in the water, and then 1 microliter of that water is used in the wells, again in the PCR plates, to monitor the freezing. So based on this, to calculate the INP particles after freezing, we should get the frozen fraction at particular temperature at and a volume V. By volume V, what I mean is there are two different, again based on the filter papers, the V is different for calculation. So the left I have shown here for PM10 filters, which I used as a Teflon filters. V is calculated as V flow by V water into V droplet. V flow is the sample air volume. when I used PM sampler to measure to gather this PM mass on the PM filter paper, so there was a certain volume sucked by the PM sampler. That is the V volume over here. And again, V water is the volume of washing water which I use. As I stated, I use 10 to 15 ml depending on the filter concentration. Also, V droplet is the droplet of water, amount of water which I use in each well. That is 1 microliter. So this was for the PM10. While for the PM 2.5 to calculate V, again it's the diameter of the punch out, that is even smaller. The punch out diameter was 1 mm, and the diameter of the whole filter paper, it was 47 mm, and V flow again is the same, the volume which the PM sampler sucked for measuring this filter paper. So from this methodology we'll get frozen fraction. So these filters are placed in the PCR plates into a well. They are in ethanol bath, they are freezing, and the frozen fraction is being monitored by a camera, and which also detects a temperature at that particular time. With respect to these, then we can calculate INP from it. So as I said, we did 2-year campaigns. So here is the plot for 2 years of INP measurements. So there are gaps in this PM10 measurements, as this filter paper was used for some other things like metal analysis and other things, and also for TEM analysis. But you can see there are like for PM 2.5, mostly for all the filters, we have this INP calculations. And the best part is, you can see at a particular temperature, if you see, INP concentrations are varying. So the higher INP at a particular temperature might be sometimes due to effect of an event. By event I mean there's something which is not in the background. There is something different, and this event might be of, like, again, it can be any kind of event. It can be dust storm, it can be polluted dust storm, it can be black carbon, or it can be local emissions. It can be many things. So from all this, so again, this for this campaign, 2022 and 2023 campaigns, again we have a lot of filter papers for 3 months, and we did the INP calculation for this by the old methods. Now for 2022 and 2023 campaign, when we combined it, we could find that there are 4 different kind of events. And I have shown here just the mean plot of all, so that it will be easy to explain you how it is differing from background to event. So this is the INP graph. INP graph like frozen fraction or the INP concentration with respect to particular temperature, because these both parameters depend on the temperature. These are temperature dependent. So we got a forest fire event. There is a forest fire event in Uttarakhand which reached Himalayas. In the Manali also we could get into our filter papers, and at that time we could see that this is the background concentration. So follow the mouse cursor at -20. Suppose what the temperature is -20. For the blue line, the INP concentration will be around 7 to 8 or 70 to 80, you can say. But at the same time, at -20 degrees, for the event condition, the concentration is more than 100. It means that whenever the event approaches, it has the property of ice nucleation. So I'm not saying that every time a thing is happening, it has ice nucleation properties, but we could find that there were 4 events and all of them have ice nucleating properties. So same goes for mineral dust event and even polluted dust event. Although there is a concept that polluted dust event, if they are having black carbon aerosols and they are hydrophobic in nature, they don't have tendency to form ice nucleation. But because these aerosols, the black carbon particles are not only the black carbon particles, they are coated. Because Manali is a hill station and we have a lot of fogs and snow areas, the relative humidity is also high during those measurements. The black carbon particles are coated, and due to the coating of the water vapor on the surface, the water has the tendency to freeze at a higher rate. So that is why when these storms are coming, they have they act also as an ice nucleating properties. So thus I could figure it out that there are 4 different kind of events. Based on all 4 different kind of events, they have different nature of ice nucleation formation. It means whenever different kind of event approaches the location, the local meteorology will behave in different manner. It means that cloud formation will have in different places, they may act indifferently. So from here I conclude my 3rd objective, to measure ice nucleating properties for different kind of episodes which are happening over the western Himalayan regions. I also compared my results with the others already published for the Indian regions. So yeah, some of the results, they are having the temperature scales up to -35 because they are using different kind of instrument. They are using spin instrument to calculate this. But I was using filter freezing method. So this has a limitation of because it freezes more before that. And these are the locations where already this ice nucleating particles have already been done in India. But as you can see, over the high altitude regions, we are still lacking. So this was the reason why I chose over there. Now, to summarize my all the topics which I have done, from major outcomes from my objective which I could get is that the dust storms, they are being identified by in situ measurements and also from the satellite measurements. The dust storms which are reaching there have two different kind of pathways. One is traveling mostly above the boundary layer, the other one is traveling below the boundary layer before reaching the interlunar regions. I classified these dust storms into mineral dust and polluted dust event based on their pathways. The dust storms events can have effect on snow albedos. It has been observed and also quantified by satellite observations. Surface snow albedo is affected by transported dust over the Himalayan region. Different categories of dust, I mean by polluted dust, mineral dust, they have different effect on snow albedo. And we could figure it out that polluted dust has the highest effect on snow albedo reduction. Aerosol complex refractive index again was calculated by based on the in situ measurements. Depending on the type, dust type, the refractive index changes. Mineral dust has mainly affected the real part of refractive index, but when it comes to polluted dust, both real and imaginary part gets affected. Ice nucleating particles changes during seasons because we could figure it out that the measurement period was for 3 months. Some has during the pre-monsoon season, one month measurement was done during monsoon season. So we could figure it out. Also, literature also says that if there is a precipitation, this increases INP particles. So again, we could say that dust events enhances the ice nucleating particle concentrations. Also, this does not depend on the total mass concentration of aerosols. It mostly depends on the size and also the composition of aerosols. Thank you.
Okay, thank you. We will start questions with Dr. Anupam. Dr. Anupam?
Yeah. Yes. First of all, I'd like to congratulate Amit for a nice presentation and very interesting work and detailed work. And obviously also Guide I must thank for a nice work. But shall I ask a few queries or my comments?
Yes, sir, please.
Yeah. First of all, that the two things. Okay, I am going from the last part. That INP, Amit, a very interesting study you have done in the last part that the dust act as a ice nucleation particle.
Yes, sir.
But what type of ice nucleate is? Whether it is a immersion freezing or deposition freezing?
It is we used immersion freezing technique, sir, for this.
Okay, so that INP basically the immersion freezing ice nuclei attack.
Yes.
So do you have any scope to look into that deposition ice nuclei?
Sir, as of because the study has already been conducted, but yeah, in future I think we can include this kind of study also to look for the deposition.
Yeah,
ice nucleation.
fantastic. And secondly, what was the supersaturation you used during your immersion freezing equation?
Sir, I mean that this because it was not a controlled environment for the supersaturation to be controlled at a particular point.
Yeah.
So at that time there was it was like I cannot comment on a particular supersaturation level maintained because these filter papers were punched and directly placed into the PCR plate into the wells to monitor the freezing based on the ethanol. Yeah, so I think for the instrument purpose we can go with the supersaturation, but
yeah, in near future I think these 2 points you please look into that because the INP is not only depend on the temperature, it must be depend on the supersaturation.
Yes.
It's availability of the moisture in the atmosphere.
yeah,
So these 2 points I think in the future you can look into that.
sure, sir.
Okay. Number 2, so in the previous objectives, you were talking about the polluted dust.
Yes.
Can we tell it is a coated dust? Dust coated with like carbon? Is it like that? Means why you named it polluted dust?
Sir,
Is there any specific reason?
Yes, sir, yes, sir. So why I mean polluted dust, sir, because when I say dust, so it means that it has most and most silica particles or aluminosilicate particles. When I say polluted dust, I mean that it is getting mixed with. I will not say it is coated, but I'll say the particles are getting mixed with all the absorption nature of other particles.
Okay.
It
Then
might
question will come whether it is internally mixed or externally mixed.
Yes, sir. So for that we have been using it's my next work I'll be doing for this mixing state analysis.
Fantastic,
Yeah.
fantastic. And last question. So what is your opinion about the elevated heat pump? Because as you are looking into the aerosols in the Himalayan region and it affected monsoon also. So what is the comments on the elevated heat pump for the impact of the monsoon? Number one. Number two, last, what is the application of your work in the modeling framework, or you can say that design of model development incorporating the results? So that will be very interesting because you have done very nice work. What is the application part of this work, of this thesis work?
Okay,
So
sir.
this is my last two questions.
Okay, sir. So I'll be answering both of them. So first question, on the effect of elevated heat pump. As I said that because these aerosols are traveling at a higher altitudes also. So, but these are not seen above, you'd say 5 to 5.5 kilometers above. Because even though if they are traveling above the boundary layer height, even Calypso also sees that it has, and if like they are maintaining the height of, or they are not reaching above 5.5 to 6 kilometers. But within that range, yeah, they are warming the atmosphere. So I could say like it will have, it depends on again location, because if they are getting trapped at a particular point, so that that atmosphere will warm and thus affect. But if they are traveling in planes, if they are going throughout, like if the measurement site at a particular location is not, if their aerosol is passing through that point of like from the origin, it is passing through that particular point. So if after a certain time period, as I show in this schematic of this transport of this dust optical depth for 9 days trajectories. So when it passes through a particular point, so it might affect for a particular time period, but after that it won't have much effect. But when it reaches a particular point where it cannot go further, it is stacked over there, it will have more and more effect. And coming to your second, if I could answer you first, I'll be answering your second question for the modeling aspect. Yes, so the practical application is for two things, because when people use this refractive index, when people calculate the radiative forcings, for calculating radiative forcing, people use refractive index, and by default they use 1.55 for the real part plus 0.001 for the imaginary part. So this is a constant which they are using to simulate their model for certain kind of radiative forcing radiative forcing calculations. But I would say that for the certain time, like for different kind of dust storms, the refractive index which they should use is not 1.55. It's rather than 1.72, which I could found based on because I cannot say it very certain, because I did found only with one polluted dust episode, but it's a way forward to other people. If they have multiple polluted dust episodes, they can monitor it. Based on that, if they combine all the refractive index, they can get a certain range which they can use instead of just a constant range for all different kind of dust storms which they are using as 1.55.
Okay, so means you are suggesting that this is very, very important, I think, conclusions to the community who are using the ESM or system model for the monsoon or tropical region study to change the lookup table.
Yes, sir.
For the aerosol directed rate. So what you are emphasizing, that we cannot take blindly from the other regions value, we can take our own calculation, and this is the high time to change the lookup table for indigenous development of the model for tropical monsoon or tropical clouds, etc.
Yes, sir.
Am I right?
Yes, sir.
Okay. Thank you very much. Thank you, Amit, and for a nice presentation and very good work and very nice work. All the best and good luck. for your future endeavor. And also, I must thank supervisor and whole department for nice work. Congratulations to you all. Thank you.
Thank you, sir.
Thank you, Dr. Anuka. Now we move to Dr. Tanushree.
So Amit, very good work and very nice presentation. I have just a few questions, one or two maybe. So first of all, I think I'll just start. I asked this question, I think, when I was reviewing your thesis as well. Whatever work you have done in the Himalayan region, what if all this work, if you carry out in some other region which is a plainer region, what are the main difference points which you think will be coming out of your work?
Yeah, ma'am. So as I stated, because if I go for a planar region, as you in the question, I could remember it was Andes you were talking about. So
Yeah.
how my this region is different with Andes. So the whole meteorology is different because even though there is also snow, but altitude of Andes is lower altitude, and they don't have a mountainous region to trap the local atmosphere or to change it. But for this region, because for Andes also I could found that they have done two kind of studies with respect to ice nucleation. I could found only few, but with respect to refractive index, I could say they are doing aerosol measurements. But because local meteorology is totally different, we are having for the Indian Himalayan regions, we don't only have this snow and snow aerosol, snow particles over there, but also we have a huge chunk of desert which is from here, which is transporting to that locations. Also, when we talk about Andes, it is very less populated. So the chances of being a particular site, the pollutions from the local emissions, they are very less. But here, as we could see, we are getting not only dust particles but also getting anthropogenic sources. And it is not only about one of them are coming alone, but sometimes they are getting mixed. So this, in this way, the Indian Himalayan regions or the Indian regions which is related to the Himalayan glaciers is a very complex nature. It is not as simple as doing in plains. So I would say the local meteorology will itself play a role. So that is why they both are different.
Yeah, so if, continuing to that question, so you are saying that the refractive index will be different. So what do you think, how much will be the difference which will be observed, or what will be the major meteorological parameter which will be affecting the refractive index?
Yeah, ma'am. So there are two, I would say not three major parameters affecting the refractive index. First is the composition of the particle, because it is not only dependent on the mass but also on the composition of the particle, which kind of particles are coming. Second, the size range of the particle, because it's also used as input parameters. Apart from the composition, that particle might be very big but might be very small. So based on the size variations also. And third will be the moisture content. How much moisture is there? So because if the particles are getting coated, if they are getting the composition is there, but if they are coating in different manner, these things will determine the change in the refractive index at a particular different locations and differently. For the Andes, I couldn't found any particular refractive index, but the worldwide used values was 1.55 for the desert, as I said before, and for here, which I'm getting is 1.73, plus minus something.
Okay, good. So I have last question. So when you were saying about these ice nucleating particles, how do you exactly quantify or measure them? Like, what is the on-ground measurement, or do you do some modeling? What is the main thing which you use for measuring or quantifying?
Okay, ma'am. So I'll explain you the methodology. So there are multiple techniques to do that. So because there are certain compounds which have the tendency to freeze at much faster rate than the you can say distilled water or milky water itself. So those compounds are to say that ice nucleating capacity they have. They can freeze faster. With as the temperature decreases, every particle will freeze. Milky water freezes as minus 38 degrees Celsius, but these particles have tendency to freeze much more before. So these all are acting as ice nucleating particles. For this study, we used filter paper method. So because I use a PM sampler, those PM samplers sampled aerosols, and those aerosols were trapped on the filter paper. Now I take the whole filter paper bunch, because they are having certain aerosol, they will have tendency to freeze faster. But at what rate? Because I did a time series analysis. So for each filter paper, I took those filter paper, placed in a PCR plate. So PCR plate has wells, small group-like structure. I place each punch into that wells, and then again I pour milky water in that. Another PCR plate I take without the punch filters. I take only a blank filter which has no concentrations. I place the blank filter each punch into a PCR plate, and again the milky water into it. Then I place both of these plates into a freezing chamber which has ethanol, because ethanol has freezing point way below than -60, I guess. It cannot freeze up to -60, but our water will freeze at -30 to -40 or even lesser than that if it is contaminated. So when I monitor both of these freezing PCR plates with the help of camera, I could monitor this each well when it is freezing. So when it is freezing, the gray shade of this camera will takes each second camera takes a picture of that whole PCR plate, and it has a grayscale values. So as soon as the grayscales are changing, it means the particles are starting to freeze in different manner. After a certain time period, the grayscale value will not change. It means that particular whale has completely frozen out. Then I compare with this from this frozen fraction from 90 to 96 whales are there. So how many whales froze at a particular temperature? Based on that, I showed you a formula before. From there we could get INP particles. When we relate with the background methods, we could say, okay, only these amount of INP particles are present for that particular period, which is in the background it is not there. So this is the method which we use to calculate INP particles.
Okay. Okay, thank you, Amit. Really good work. All the best for future endeavors. Thank you. That's it from my side.
Thank you, ma'am.
Thank you, Dr. Tanshri. We don't have any DC members here, so I'm just going to ask some questions.
Sure.
Can you go to your conclusions? Okay. So you have listed number of points here. My question is, which of these are common knowledge which people already knew, and which have come out of your research, specifically from your research? Some of it, people might have intuitively known, but some might be entirely new, maybe counterintuitive. So can you tell me, which are drastically new kind of conclusions?
So, okay. I'm not sure about the whole word, but as far as I know, there are 3 new things over here, which is three points which I will focus on. The first thing is that the classification of dust storms. This was not known before. So there is no classification such as this is polluted dust and this is mineral dust. So first thing which I gave to science is that it is not only about a dust storm, it is about different types, and also showed why this different type matters, because they have different effects. So this was the first thing. Second, it follows the first, because the polluted dust storm was not known, so its refractive index value was also not known. So that's why people were using 1.55. It's a constant value which people are using for every models for every location throughout the globe. But it is not at a particular. It is not for all the places. It differs from place to place, and also it it's related to meteorology and other conditions. So second thing I gave is that the important point is that refractive index value. It's region dependent, and it should be for Indian region. It should be different with respect to different kind of dust storms. Third, we said that ice nucleating particles is that black carbon concentrations are supposed to be hygroscopic in nature. They don't attract water. But we found that when there was forest fire event or polluted dust event, but we have increase in the ice nucleating capacity. It also tells us that although itself black carbon particles is not it's not ice nucleating particle, but black carbon does not remain as black carbon in the atmosphere. As soon as it emits, after a certain time period, it gets aged. By mean I aged, it gets mixed with other kind of particles. It gets coated with other kind of particles. Thus, its effect also changes. So this black carbon particles is not ice nucleating particle. It is known. I am saying when it is getting coated with other particles or hygroscopic in nature, it is getting coated by water molecules or other substances, it becomes ice nucleating particles. It acts as an ice nucleating nuclei. So these are the 3 points which I would say.
Very, very good. Very good. Okay. Professor Shiva. Shivanagendra.
has asked a question.
Okay, you can read out.
How is the metrology different in transporting and accumulating dust?
How is metrology?
How is metrology different in transporting and accumulating the dust?
So, sir, okay, depending on the metrology, how it is being transported and accumulated. So, sir, are you asking about a particular place methodology where it is being transported or accumulated, or in general from where it is being transported, or like, can you please clarify?
So, Professor, you are not audible. But what it means is, you are talking about metrology. There are two parts, transportation as well as deposition or accumulation. What are the different processes? As previously you have mentioned that metrology matters.
Yes.
So process level, I believe.
Okay, so sir, for transportation, it's mainly a wind factor plays a role. Also, boundary layer dynamics also plays a role. So, if aerosol has to transport like elevated aerosol layers, so the aerosol should get shoot up. So now it will not be affected by local meteorological condition. Only wind pattern will govern its transport from particular place to other place. While when it goes for this in the lower boundary layer, the lapse rate also matters. Like the stability of the atmosphere matters. So if the atmosphere is stable, the pollution will be accumulated at a particular place. The atmosphere is not stable; it is unstable. It might get mixed and might get again. It can be transported within the boundary layer to a particular location, or even shooted up and then transported by the elevated aerosol layers to the particular location.
Okay, ma'am.
Professor Shiva?
Okay, and so now we take questions from the audience. This is the informal part of the Viva. So if anybody who wants to ask, you can. Yes, please go ahead.
You're saying refractive index is an intrinsic property,
Yes.
but you are also mentioning it depends upon the size.
Yeah, so-
Are those contradictory?
No, so by the size I mean when we calculate through the model, we use size parameter. Size is not, I'm saying if the, so intrinsic property, it's by mean the smaller the size, the composition will also vary. So each composition has, when we examine this composition, so when we use CC-SEM and other particles, we could see that each composition has its own particular size range. So by I mean that it is intrinsic property, it does not depend on the concentration or the total mass, but it depends on the number of the particles or the size range of the particles.
So you have classified like dust events and polluted events. Polluted events are those in which they have black carbon. But like, is there a threshold? Let's say the ratio of PM and BC is this much, so then I call it as a polluted event as compared to dust event.
Yes, so for all those 10 events which could identify, so there was two ratio. First ratio was to get and dust event itself. So the ratio was the PM10 to 2.5 ratio should be greater than 2. And also, it doesn't mean that if you have PM10 concentration of 10 microgram and PM2.5 is of 5, it is a dust event. No, it is a normal event. So also the PM10 concentration should exceed a threshold value of 100 microgram per meter to quantify as a dust. Second, to quantify as a polluted dust, a metric was given that the black carbon concentration should increase by around 95 to 100% with respect to their background conditions. So this is the criteria to decide.
Okay, any other questions? Okay, so we have come to the end of the Q&A. Before I proceed, just want to check with the examiners once again if you have any final comments or questions. Dr. Anupam, any final?
I think no, it's a very good work. I think we should recommend Amit for his good work.
Dr. Tanushree, you have any?
No, Professor Benny, I think it's a really good work.
Okay, so We have the report from both the examiners. Both examiners were very positive, and both of them have recommended accepting the thesis in the current form. And very positive comments with just questions which are just clarifications. There are no fundamental issues. And you have given a very nice presentation today, neatly summarized your work, and you have satisfactorily answered all the questions from the examiners as well as the audience. So based on your thesis and based on your presentation and having satisfactorily answered all the questions, I declare that you have successfully defended your thesis. So congratulations.
Thank you.
Would you like to say something?
Yeah. I've been waiting for so long for this moment. I don't know like what to say, but this day is
Dr. Amit, now you can bring your face in front of the camera. Yeah, right.
I thought I was visible.
Now you are Dr. Amit, official.
Yeah, thank you, sir. So yeah, this journey started way back when I gave a proposal to work on the Indian Himalayas, and really I was very happy when it was got accepted. Like Chandan sir said, like yeah, we can work, but slightly we have to deviate to topic. I was interested to work on the criconites, biogenic sources of yeah, but then he said that we might work on different things because he's a physicist, not a biologist or botanist. He said that you can work on different aspects but on the same domain because you are very much interested. So yeah, we formulated a few hypotheses which we could figure it out over there, and we did. And there were lots of ups and downs for this because the campaign was enjoyable and hectic both. There were a lot of changes in the manuscript itself when we are writing, but it all teaches us, actually particularly taught me the patience of life. I should bear that throughout my whole life. I should have patience if I have to write a manuscript in a good journal at least. And yeah, there were lots of like things which I didn't knew, and I couldn't do it without my colleagues and friends over here. They helped me a lot in a lot of different things because the background was totally different for me. I was a botanist, not even a coder, but now at least I can write a few lines of codes. And ChatGPT came later on, but there were my friends who were helping me with that, who knew coding very well. And also the guidance from sir, how to make graphs. I made my best, but again the question comes, this is useless. Not a particular useless word, but this can be modified into better. So this was his phrase, because useless might demotivate me, but this might be a better thing if you do it this way. It encouraged. Sometimes we get depressed, right? We are fed up of making it 1,000 times, but yeah, this is how it goes, as you all know. So it went, and I learned a lot from this. And I was very nervous before I started my presentation. How will I do? Did I do enough work for the science community? Were I able to defend it very well? What I did? Were I able to deliver the way I did and the things I faced for this PhD? And I don't know how I did, but thanks to all who all listened over here. That's all I have to say. Thanks.
I would like to congratulate the guide also. Chandan, you'd like to say something?
I was not that well prepared as Amit. But yeah, I also am, it's also a learning thing, and Amit always took up the challenge, as he was humble enough to say all this, but every time I put up the bar, he took up the challenge, and I am happy with the output. Still we have to complete the papers, but overall the amount of hardships, so it's not logistically easy to go to Himalayas. Just think of him as a second year student, he took up the challenge very seamlessly. He stayed there, he did all the campaigns because of Amit, I would like to say, and also congratulate, keep that attitude, you will do very good in your life. Thank you, and thank you for the department also, it's very supportive. Whenever we need any research help and support, the department and institute was very helpful. And thank you reviewers also, your reviews were always instrumental. Professor Shiva also helped a lot. His instruments we used for OCAC analysis, and it was very at a point of time when we were having a lot of samples. He encouraged us to do it. So thank you, Professor Shiva, also, and the reviewers. Thank you, everyone.
Okay, I would like to officially thank the examiners, Dr. Anupam, for taking the time for correcting the thesis, meticulously going through the thesis, and for joining here today, spending this time. So thank you, Dr. Anupam.
Thank you so much. Thank you.
And Dr. Tanushree also, she is on leave, but she
Took out time, yes.
took the time to. Thank you, Dr. Tanushree.
No problem. Thank you so much.
So we will send the minutes for your signature. So you'll scan and send
Sure.
it. So you can, if you can quickly send it back, we will complete the process quickly.
Sure.
Sure.
Okay, and also thanks to everyone who participated in this session. So we close the meeting now.
Thank you, Professor Venu.
Thank you, sir. Thank you, Dr. Sandhu.
Congratulations, Dr. Chandel.
Thank you. Thank you. Thank you. Okay, see you, doctor. Thank you. Thank you.